Okay, about another minute or so, and then I'm going to start going through these theorems and explain how they work and why they work. And we'll try a few problems together. Okay? So while you're finishing up that, I'm going to hand out some of your assignments here. Actually, I better wait on them. Don't want you to start that. Yeah, some people would. How many are done copying them down? How many are almost done? Okay. Okay, hey, so Theorem 10-4. Theorem 10-4 is the side splitter theorem. It's got one of the coolest names in the book. Yeah, it does sound kind of violent. But the side splitter theorem is it's one that helps us with all three of the, it helps us with the other theorem in the postulate today. So let's take a look at, or the corollary, excuse me. Let's take a look at that. We got the QR is to Rx as QS is to SY. Okay, that's what the theorem actually says. It says that this side right here is proportional to that side right there, or that segment right there. Or this is to that as this QS is to that. So this ratio is proportional to this ratio. All right. So hopefully the inquiring mind would say why. I would hope that. I know that some of us we kind of memorize it and just move on, but why is that the case? Anyone know? Jordan, what do you think?
Well, because if they're parallel, they would be going this. If it was parallel to a side, then it would be going the same direction as the side, and it would line up, and so it would cut it in the exact same way because it would be straight on.
Okay.
That makes sense. Like it makes sense in my head, but I can't say it out loud.
Yeah. Hey, and mathematically, if you're trying to prove this, I mean, how many can see the three triangles in there? Or the two triangles. I guess you have that one, and you have that one. The two triangles. So this big triangle is similar to this small triangle. And we could prove that by angle. These are corresponding angles because these sides are parallel. And they share an angle, right? So we can say that triangle, you guys see that? Triangle QRS is similar to triangle QYX.
Maybe
QXY, thank you. Okay, so we've got those similarity pieces, which tells us that this side right here, QX, is proportional to what? QR. So since this is true, we know that QX is proportional to QR. And we also know that QS is proportional, tell your neighbor. QS is proportional to what? QY. Okay, so this is proportional to this big side. This is proportional to that big side. Okay, pay attention. All right? Why is this statement true? Coming from this, why is that true? I want you to try to figure it out with your neighbor. You guys get about a minute to just talk about it. Okay? Hey guys, I want full participation. The other way we do this is I actually have you write the full proof on it. Okay? So full participation on it. Talk to your neighbor about how you can get from this statement to that statement. What can we do? Okay, time's up. Any ideas? Eli?
You just add Q to all of them?
Huh?
You add Q to all of them?
You can't just add Q. No. Hey, QX is made up of what two segments? So this QX is made up of QR plus RX. Okay? And how about QS? What's QS made up of? QS is made up of, excuse me, Q. Do I have this mixed up? Do I have this upside down? I do have this upside down. Holy moly. That's not helpful. That's QY, right? The entire to, all right, to QS. All right. Let's go with QY. QY is made up of what? Good. QS plus SY. All right. Can anyone see how we're going to get from this to this now? Use these. Give you another 30 seconds or so. I'll answer. Yeah, sounds good. Okay, here we go. Anyone have it? What's that? Yeah, Nick?
Isn't it because if it's QR to RX, isn't it because the lines are made up of the whole line with Q? So if you have QR and RX, that equals QX.
It does. We've got that here, but we're trying to get to this. Okay, let's do this. Let's substitute this in for that. That then gives us QR plus RX over what? QR. Equals, and then let's substitute this in for that. So that now gives us QF over QS. How many are with me right now? Okay, now from here, can we just cancel QRs? No, you got to cancel the whole thing. Or think of it this way, QR plus RX over QR is the same thing as QR plus RX over, each one has a QR. And then QS is QS over QS plus SY over QS. And I heard some of you say, hey, you can cancel that. That's true. This becomes 1 and that becomes 1. We subtract 1 on each side, we have RX equals, or RX over QR equals SY over QS. Hey, dude. That's that. Total whoa. Except for it's flipped. But that's okay. It still works, right? Cross multiply, we get QRSY, QRSY, RxQS, RxQS. Cool. That's why it works. You guys shouldn't just memorize things, man. Yeah?
I thought that you couldn't,
Like flip it?
oh wait, never mind, I got it.
Okay. Hey, so what this really says is if I take in, say, put in numbers for this, if I put in, say, 5 and 2 and 3 and J, okay, 5 over 2 equals 3 over J. That's all I'm doing. I'm just like putting a big division bar right there and one there and putting an equal sign. Everyone see that? 5 over 2 equals 3 over J. So 5J equals 6. Oh, thank you. 5J equals 6. So 1J is 6/5. Pretty neato? All right, let's move on. Side splitter theorem, let's go to the corollary. Everyone tell your neighbor what the corollary says. Hey, time's up. Hey, someone tell me what this corollary says. Go ahead.
If three parallel lines intersect two transversals, then the segments intersected at the transversal are proportional.
Good, so these were proportional. So in other words, A is to B as C is to D. Now you have to focus on the parallel lines, because some of your pictures today won't look like that. They'll look like that. And some of you go, well, I can see parallel. Well, sometimes they're going to draw a line here and they're not going to mark it parallel and it's going to look parallel. Say, for instance, you may be given this problem. Whoops, don't want to put the actual answer up on. Look at this one. Number 4. Off example.
That's not parallel.
Yeah, you got those lines. The parallel are running that way. So you've got to think of the picture as looking like that then. That is to that as that is to that. See what I mean? Make sure you're looking at which way the parallel lines go. It's a transversal that cuts parallel lines. Yeah, it's pretty cool. All right. Hey, the reason this one works, I don't want to spend as much time, but it's based on the side splitter theorem. If I draw a line from here to here, everyone see that? I've now made two triangles. I've made this triangle right here. You guys with me? Okay, I'm going to call back, so I'm going to call this one W and this one Z, these points. And we've got this point that I'm going to call S, and I'm going to call this point Q. Okay, I know that Q is to, or Q, I guess I should label this one, let's call this R. QR is to RS, right? As WZ is to ZS. Everyone agree with that? Okay, based on the side splitter, this is to this, as this is to that. You guys with me? How many see the other triangle? Okay, from that triangle, we could get what? WZ to ZS as? Oh, we need another point. Let's call that one like X. That one Y, just because we're creative like that. Okay? How many see that? Okay? By substitution, that is equal to that because these two things are the same. Right? We substitute this piece in up there. That means QR is to RS as WX is to XY. Pretty neato, right? A is to B as C is to D. Okay. How many got it? Okay. Let's try the next one. Angle bisector theorem. Now the book says this one a bit differently than I would actually use it, just because I think I'm cooler than the book. So that's not really why. No. Let's say I have a length here. Let's call this X and let's call this 8. Let's call this one 6 and we'll call this one 5. So from here to here. Okay, the book says 8 is to 5 as X is to 6, right? Which, if you think of that, 8 is to 5 as X is to 6. All right? That actually gives you, when you cross multiply, you get 5X equals what? 48. Now, I like to look at it a bit differently. I like to look at it this way because it lines up well. I like to look at it as X is to 8 as 6 is to 5. Is that true? Well, the way you would know is you'd cross multiply and look at the same proportion. It gives you 5X, and that gives you 48. So yeah, they're the same thing. So you can think of it both ways. I just like it this way because I could put fraction bars and say that. And I have what I need. Okay? All right. Hey, I'm not going to go through the proof on this. For those of you that would like to see it, real quick, I'll draw a picture while I'm handing out the paper, or draw a picture while Eli's handing out the papers. Thanks, E. Nick will help you too if you want. Just because you guys are super swell. Okay, he's handing out the assignment. You guys just watch the magic of artwork.
Sorry, Andrew, I didn't mean to.
He,
Wait, one second. Okay, never mind.
Andrew, I heard them talking about it at lunch.
Yeah,
Hey, later, when Mr. McCoy asks us to pass out papers, step on his foot. How many saw what I did there? You're not watching Nick and Eli.
Hey, look, you extended it.
Isn't that amazing?
Yeah, it's
I know.
Well, thanks, Nick. Another angle.
Hold on now. If you really pay attention, you'll actually see what I'm trying to do. Oops. Let's go to right there. How many are really paying attention? Cool. All right. The line that I just drew in is parallel to that one. Now you see that? Cool. I can now do side splitter theorem. This is to this, as this is to this thing. Let's call this, just for a second, Y. Y, just because we're calling it Y. So we've got x is to y as 8 is to 5. Well, here's the deal, and it goes this fast. This angle, this side right here, is parallel to this one. So therefore, this angle right here is congruent to this one. How do we know that? Alternate interior. Good job. And this angle is congruent to this one. How do we know that? Corresponding. And these two were given that they were congruent. So that means this triangle is a... No, this triangle is a isosceles triangle. Hey, and sides in an isosceles triangle are congruent. So that would be the same thing as that. So that would be y. That's why that works. That's pretty cool, dude. Okay? So anyway,
That's kind of cool.
that is really cool. Brad, bless the picture, looks really cool. Okay? So let's try some of these. Let's look at number 1. Everyone give number 1 a go. Example side, number 1. In the building. Just saying. X over 6 is equal to what? Yeah, so it's this over this equals that over that. 20 over 5. That's one proportion. Okay, we could actually say equals y over 5.5 right now, but if we're trying to solve for x, that doesn't help much, right? Cross multiply, 5x equals? Uno 20. X equals? Uno 20 over 5, or also known as 24. You guys got to tell me when I'm off the screen, man. Unbelievable.
Listening skills.
Huh?
We're using our listening skills.
Use your visual skills too.
But we're using our visual skills for the
You should use just your visual skill. I'm saying, yeah, just the visual.
What are you implying here?
I'm not implying.
That too.
Okay, 20 over 5 equals what? Y over 5.5. Okay, so this over this equals that. We get 5.5 20s. Dude. Yeah.
Could you do 24 over 6 equals y over 5.5?
You could use 24 over 6. Yeah, that would work as well. I think that's 110, right?
Yeah.
Equals 5y. So y equals 22. Cool. Everyone knows how to do 5s quickly. How many 10s go into this? 11. We just drop the 0. 5, you just double it because there's 2 5s for every 10. 22. Yeah.
No way.
Total way.
Yeah.
All right. Give number 4 a go. All right. Here, I'll make it so we can actually see it. There we go. It's easier to see that with that light on.
Yeah.
Oops. Not that light.
That's good. Yeah, we're at small.
That's good. Cool. So y equals 21. X equals 18. That what we got? How did you get 21 so easily?
Because 14 is equal is the same length as the other one.
Good, yeah. Hey, so first thing you have to recognize parallel lines are running the other way. And then once you recognize that and you see that 21 is to 14 as y is to 14, these 14s are the same, so the tops have to be the same. So this is 21. You could go through the whole process, but you'd still get 21. And then 21 is to 14 as x is to 12. Notice Maddie, she simplified this, right? 14 21st is 2/3. And so you can simplify that to 2/3, and that will still give you proportionally the same thing there. So cross multiply and divide, you get 18. Okay, how many got it? Okay, very good. Hey, we're done with the example 1. Let's go on to number 7. Number 7. Someone raise their hand and tell me what proportion I can form. Andrew, what do you got?
5 to x is 6 is to 4.
Good. 5 is to x is 6 is to 4. Just there we go. 5 over x equals 6 over 4. Aha.
Good for you. Sure.
Okay, what equation does that give me, Jacob? What equation does that give me?
It gives you 6x equals 20.
6x equals 20. Okay. Lucy, what solution is that?
Well, I got 9 and 1/3.
20 over 6,
Yeah.
which is 10/3. Very true. Which is 3 and 1/3, if you want to leave it like that. Okay, let's go with 10/3. Hey, any questions? Why don't you take a look at the mixed side, number 16. Everyone work that one out. Give it a go. Bennett, you hanging with us? You get it? Yeah? Not really? None of it? We should talk here afterwards. Okay. Hey, so this one becomes x over 6 equals x plus 1 over 9. How many got that? Made it that far? Okay, we got the proportion. Cross multiply, we get 9x equals
6x plus 6.
good, 6 times x plus 1 or 6x plus 6.
Can't see.
Thank you. How many can actually see the board from where they're at? Okay, when I go off the board, since I'm facing you,
No.
I need more than just Nick going, you can't see it. I appreciate it. Hey, that's not very nice. Okay, we get 3x equals 6, so x is 2. Lily, you got all these seats right here. Yeah. All right. How many got x equals 2? Okay. Last one, number 14. This is the example side now, sorry. I know. Oh, I had to turn the page. Oh, no. Okay, let me pause you for a minute. Can I use the tic-tac-toe board?
No.
Why?
It's not a right triangle.
Not all of them have right angles.
They're not all right angles. Okay? Now I use the tic-tac-toe board here. Hey, what proportion can I set up? So these are the same, right? Think of that last theorem we had. So if we look at the triangle, it was sat like that in the theorem that we had. We had the two angles. 5 is to x as 12 is to this thing. Everyone see that? Okay, well if we go 5 is to x as 12 is to, what is this side length? Yeah.
If you use the Pythagorean theorem and find 12 squared plus 5 squared equals 169 squared about 13. Okay, I could have just said the answer, but that's too cool. And then you could just get 13 minus x because it's the whole thing. Yeah.
Okay, so this whole thing is 13. Okay, so this piece of it, if I have from here to here is 13. Here to here is 13. I want to go back to here. So what am I taking off?
13.
X. So I'm at 13. Take off that x. 13 minus x. There to there minus that. Now we can solve. What's that give us? 65 17ths. Totally sweet. Okay, you guys did a good job. We'll make it just mixed side.